So now we're going to go into some more challenging questions. So this first question I think is actually more challenging than the second. So let's go over the first question first. So what this first question wants is we want to define a function deep map that takes in a function f and maps that over a list that could potentially be nested. Okay, so I feel that we're pretty comfortable with writing a map function for a list that's not nested, but how do we do this for potentially nested lists? That's the key idea here. So of course take some time, see if you can figure it out, but I'm just going to go through this type of problem. So let's go. Alright, so deep map is up here. So let's take a look at some examples of how this works. So we want to map the function f over a list that potentially could be nested. Okay, so here's an example where we have a non-nested list. Okay, so we take the lambda function and we map it over. Okay, that seems very straightforward. Then we also have a square function, and then we map the square. Okay, so now we have a nested list. And you see that the structure of the return list is just the same as a nested list, except of course the mapped function is applied over all the elements. Okay, and here's another example of that. So this is the basic idea. Okay, so how do we approach such a problem? Well, I like to think in terms of what I know. Well, I know for sure, again, let's think of simplest possible cases. So generally a good case with lists is you want to check what if the list is 0. So length of list 0, what does that mean? Well, we just return the list, right? Because there's nothing to really map over, so it's just whatever the original structure of the list was. So let's write that code down. So if length of the list is equal to 0, we just return the list. Awesome. So now, well, really there seems to be two cases in this problem. Either that the list is nested or it's not. How do we check if a list is nested? That's a very, very good question. So I'm actually going to show you a trick for that I haven't really talked about, but I think it can be possible to intuitively come up with this. But let's just look at this. So if I define a list that's nested in any way, shape, or form, I know for sure that if there's, so what's the first element of this list? I know that that's just another list. So here's the key idea. An element inside the list has to be a list for the list to be nested. So let me repeat that again. An element inside our large list, our entire list, has to also be a list for the list to be nested. So that's the key idea. So what we can do is we can just check the first element of the list every time as we go through the list and make sure that's list. So the way we can do that is we can just check if it's list. And in this case, this is a nested list, so it'll return true. So here's the key idea. So there's my condition. And it's okay if you didn't figure this one out because I didn't really talk about it too much. But if the type of the list, so I'm actually going to, I want to think about my easier cases first. What if it's not nested? So if it's not a list. And if it's not a list, that means it's a number. So we have to map something over it. If it's a number, we have to map something over it. That's the key idea. Okay, so how do we map something over it? Well, and I need to return it as a list, right? So I take a list and I map my function over this first element. Okay, and also, my bad here, it should be list of 0 because we're looking at the first element each time. So what this is going to do is it's going to return a number because this list 0, this first element of the list is a number. And so once I have that, well, the rest of this list is just a matter of mapping the same function over the rest of the list. Well, how do we do that? We can do that with recursion. So here's the key idea. Deep map on the rest of the list. How do we get the rest of the list? Well, we just do this handy syntax, list slicing. Okay, now here is the trickiest case. What if the list is nested? So what this means is basically list is nested, or let me be more clear. First element of the particular list is a list. Okay, what does that mean? Well, let's think about that. So I like working a lot with examples. So let's look at this example right here. So let's say this is our current, let's say that we'll just call this the list, okay? We know that list, the first element of this list is another list that's composed of 1, 2. Okay, so from this, how do I get 1, 4 from 1, 2? Well, what I do is I map the function over this smaller list and return that. So here's the key idea. So we can now actually do recursion on this as well. So return deep map on my list of 0 because, and oh, also one thing I forgot. Don't forget the first argument. Deep map takes in 2 arguments. That would have caused an error. So we basically map the function over this inner list, and then once we have that, we're going to trust that it gives us this output, and then the rest of this is just created by going through the rest of the list and mapping the same function. So here's the key idea. We deep map on the function with the function and the rest of the list. So this is quite a lot to process. So let's actually see if we can deconstruct this a little. So when we call list of 0, our new list is basically this. So this is our new list. New list. So that's our variable list is bound to this. And so what's it going to do? Well, it's going to check if the length of the list is 0. It's not, because remember, we're passing it back into the function. So our new list is going to be the list of 0, which is 1, 2. Okay, so we pass it back into the function. We check if the type of list 0 is not a list, which is true because now the first element of this list is the number 1. Okay, so that's great. We call the function on the list 0, and so that returns this, and we're going to deep map on the rest of the list. Well, we know the deep map on the rest of the list, so we're going to look at this call. So basically we're taking this call and we're going to see what it returns. So I'm going to be a little lazy and skip a few steps. There's one more recursive call in here, but basically this is going to return 1, 4. Okay, and oh, so now we notice a mistake. This is only going to return 1, 4. I need it to return another. It basically needs to be around another set of brackets. So the key thing here is to notice that this has to also be around brackets because that's how we're going to get the nested structure. So again, I actually did this on purpose because I want to show you that it's important to also trace your recursive calls occasionally, but this is a very easy error to make. So let's take a look at this. And it works. So that's our deep map function. And if you really want, make sure you go ahead and put this into an environment diagram and see if you can trace over the recursive calls and see how they work. Because this is a very clever solution to this problem. So, and it's okay if you couldn't figure this one out because this was a very challenging problem.